How are you today? My name is Roy Benalta, and I'm a part of our business development team covering the analytics and machine learning services at AWS. I've been with Amazon Web Services. This is my 4th year plus, so I started my career as a solution architect, worked with customers on building machine learning and data analytics solutions. And together with me today, we have Chris Azima from the Washington County Jail Police, and we have an unusual title for this session, which is the unusual suspect. We try to be creative, but basically you will learn how the Washington County Jail using Amazon AI Rekognition to identify persons of interest. So this is a 200-level session, so it's for folks that don't have experience with AI or machine learning. They heard about it, they read about it, they want to learn more about what we have at AWS, how you can use it. And so I'm going to give a quick overview about Amazon AI. You probably will hear for many sessions. There are deep technical sessions. I don't know if you had the opportunity to participate in one of them, but there are going to be many of these in the following week. Then we're going to play a little game. We'll run a demo together, so hopefully your all mobile devices are working, so we can do a live demo with one of the solutions. I will go through the architecture of how this demo was built, so if someone wants to build it after this session, you can actually look at the source code and build, and then we have Chris to show the use case of the Washington County Jail and how you build it. So let's get started. So artificial intelligence in Amazon, if you think about it, Amazon are doing machine learning for decades. Since there was a bookstore, they already had personalization and recommendation for what Amazon is doing. But if you think about Amazon business today, there are so many different business units and different organizations that are using artificial intelligence like Alexa, our fulfillment centers, and Amazon has thousands and thousands of engineers and practitioners and researchers that are focusing on different type of workloads that running artificial intelligence and machine learning within. So if you think about fulfillment center, when you order something at Amazon, there are robots that actually run across the fulfillment center using computer vision and sensor detection and different type of technology that can have an autonomous robotics that running the supply chain. If you are using, anyone heard about Alexa, Echo? So Alexa has using automatic speech recognition and natural language understanding to build it. So there is actually many areas that AI is now part of any software. And with that capabilities within Amazon, last year we created a group which called Amazon AI, where our mission statement is really to bring to every developer, to every data scientist, whatever your level of expertise, to use these type of capabilities. And the way we look at it is on these layers. So the top layer, what we call Amazon AI services, there are a bunch of services for vision, for speech, for language that use an engineer, a software developer that knows nothing about deep learning or machine learning or build a model. You can use a simple API to innovate and add more advanced features to your softwares, as well as creating new products. At the talk of Chris, it will show you how they use one of the services under the vision category. So what we have in the AI services. So the first service is Amazon Rekognition that does image analysis. And I'm going to talk about each one of them. The next one is Amazon Poly. So it provides you a text-to-speech service. So you can take a text and you can create an audio with that. And Amazon Lex that allows you to create conversational bots and using the same engine as Amazon Alexa. So Amazon Rekognition, the idea is that we take data, and if you look at pictures, there is data in the pictures. And today, me as a person, I can say it's a hot dog or not a hot dog, right? But What Amazon Rekognition does for you, it using the models that we already built, and you send a picture or an object that has, and we do an object and scenes detection, facial analysis, face comparison, facial recognition. We also added celebrity recognition this year, and also image moderation. If there is a nudity or something, you can get these alerts. Last week, we also added text in image, so you can take a picture of a driver license or menu, so you will get the text within the image. So think about if you have some images that you want to extract text from it, you can use that. So that's something new from last week. The next one is Amazon Poly, and as I mentioned, Amazon returns an MP3 or an audio stream from the text. The different use cases that you can use that for content creation, mobile or desktop application. Think about IoT, you want to build a smart home, so you can take a text and actually convert it to an audio. It has many features, like for example, you identify the punctuation. If, for example, you say something in a different region, so I'm originally from Israel, you can hear from the by the accent, but it can have a regional accent. So, for example, in some places where you spell Kaja, it can be sound like Kaya, etc. And Amazon Lex provides you the way that you can go to the console and build a conversational interface for your applications. And that's powered by the same natural language understanding and the automatic speech recognition as Alexa today. The polarity around it, around use cases, so you can build an informational bots, for example, what is the status of the order, like for example, or you can do, for example, to book a flight reservation. So we have several templates today that exist, but one of the interesting things that we've seen with Amazon Lex, last year we introduced Amazon Connect. Sorry, it was this year. And Amazon Connect is our contact center that you can create your 1-800 line and route within the calls. But you can actually now take Amazon Lex and build a smart bot. So instead of person to answer a phone, you can actually have a bot talking to the person or the customer that called, and you can automate your contact center. But really, there are so many type of use cases that you can use with Amazon Lex. And in addition, there is also a feature if you build, you can import skills that you build with Alexa to Amazon Lex. So that's another. Who are the users that are using this are developers, as I mentioned. However, in some cases, in our organization, we need to build a specific machine learning algorithm. We have specified data that we want to train and do things like binary classification or linear regression or clustering and using machine learning. So this is where the AI platforms come into place. And in the AI platform, we have several services. The first one is the Amazon Machine Learning. And Amazon Machine Learning is a managed service that fits to the use case when you have a clean data set, you want to run a binary classification or linear regression, supervised machine learning algorithm, and use it. So you can connect to the data source, it will train the data, create the model, and you can deploy it. After all, you don't need to be a data scientist to do that. However, if you are looking into using R or Spark ML, you can use things like Spark and EMR today to run machine learning. The reason I highlighted these two services like Kinesis and Spark and EMR because we're going to show you a demo of how we use, for example, Kinesis within the demo that I will show you later on. We also have the Mechanical Turk. This is a way for you to label data. So if you're not familiar with Go, it's very popular. So sometimes you need to label data, and you can pay people just to do this labor and have a good data that you can usually use it later on for your training purposes. And let me just go through the two services. So what is Amazon EMR for those that are not familiar? So Amazon EMR is a managed Hadoop and Spark framework. So basically, you can run any type of distributed engine. We have more than 16 applications that you can run today with Amazon EMR. If you're familiar with Hadoop, the idea with EMR is that you can build a data lake and now run and train all your data within your organization when you put it on S3, or you can use it as well as if you store it on HDFS. And what it provides for developers, the end user are usually our data engineers or data scientists. Data engineers to me are the same. But if you think about it, you have the ability to run multiple experiments in parallel without really impacting each other. One of the common problems that we've seen in the past from customers is that we have a Hadoop cluster, we have a data lake, or we have a data warehouse, and we have reporting that runs against that type of environment, but we also have a data science team that wants to build models and they want to train the data. We heard from customers, hey, the problem is that we cannot run this type of workloads during the business hours because they are reporting that running against the same environment. So what you do with Amazon EMR, you can create multiple EMR clusters. So we have customers that are running millions of them, and you separate between the compute and the storage. So your data is on S3, and now you can have different teams using different tools like Redshift or Athena or EMR to run this type of workloads, train their data without really impact each other from performance. So pace of innovation is really increasing when you do that thing. Amazon Kinesis, and that's one of the services we use for that demo. Amazon Kinesis provide you a managed service to stream data in real time. I will talk about Amazon Kinesis Analytics because that has a machine learning capability. For real-time data, you can run an anomaly detection, and you can do a multiple aggregation, time windowing, sliding window, real-time filtering for data that comes in real time. So think about IoT when you have many devices connecting and you want to analyze them and using machine learning to build this type of prediction or build a recommendation engine. Customers are using a Kinesis as a storage layer for real-time clickstream data that now you can have an actionable insights based on that. The last layer is really the frameworks and the infrastructure, and this is where what we did, we introduced our deep learning AMI, Amazon Machine Images. The deep learning is a subset of what we call the machine learning, where you can do things that the math was exist like for years, but you need a lot of data, but you need a very, very, very strong CPUs to run deep learning workloads. What deep learning does, it's using a neural network. So if you're not familiar, there are great sessions of introduction just for this domain. But the idea with neural network is that you can do things like computer vision or natural language processing, tasks that as a human we're doing it today, but you can let the machine actually learn. Look at millions of pictures, and now I can identify for a new picture if there is an animal on the picture. Or, for example, you want to count how many people here just by taking a picture and tell you how many people are here. Of course, it will give you this number with a confidence level. It's not 100% accurate, but if I take someone here and tell you, hey, count how many people are here, you will not have an accurate number in 1 second, right? But the machine can actually give you something that's on the range that an average like a human being giving these numbers. Now, how you do this deep learning framework, and this is where what we have today is there are a lot of frameworks that in the market today. All of them are open source actually. So we have TensorFlow, MXNet, Keras. Cafe in Japan, they like to use a framework called Chainer, for example. I met customers in Japan and they use Chainer, for example. What we did is we wanted to give customers the choice to run any deep learning framework that they want. And in order to reduce the learning curve, and if you're an engineer and just new to that, we also introduced in the last 2 months a new framework called Glue on Interface. So it's an open source, and basically it's a framework with code libraries that you can use, Python, and build your models and algorithms and train the data set in a quite straightforward way. The challenge is always with the deploy and how you do the training and the iterations, etc. So Gluon supports today Apache MXNet. So Apache MXNet is our open source deep learning framework. And again, you will choose the framework based on your use case. You can experiment with customers that are using both MXNet and Caffe2 or PyTorch or Keras or TensorFlow. So there is no favorite deep learning framework that we think. Amazon did a lot of benchmarking for different use cases, and the reason we decided to use Apache MXNet and contribute to the open source is based on the performance metrics that we did with some benchmarking. But again, it doesn't say that you must use that framework. What we provide with the Amazon Machine Image is and totally ready and EC2 instances that you can run now all these type of workloads. The infrastructure is really interesting part because you need a very strong CPUs to run these type of workloads. So we have the P3 instances, which are Volta. And for those that never use that, what it means, in the past, when you need to run this type of workloads, you run it on many machines with GPUs, graphical processing units. And sometimes training can take weeks, or it can take many days. And with the new P3 instances that are powered by NVIDIA Volta, the days actually reduced to hours. So think about the amount of experiments that you can do with this. And this is why deep learning and AI become very popular, because now you have this capacity and capability to run these type of workloads. Now, if you are, as you know, AWS, you can use our Spot instances. You can use things like Amazon ECS or Amazon Batch and run these workloads. Once you finish your training, you just turn off your machines and that's it, and you have the model. In addition, you can take the models and deploy it via tools like Greengrass. So for example, if you want to build a device that already have embedded model inside, you can use our Greengrass. So you can do the compute on the edge itself and also a mobile, etc. So again, this is the third layer. These are for more advanced practitioner, but really you don't need necessarily to have a PhD under your umbrella. So I call myself, I'm a pseudo data scientist. I don't have a PhD, but that's what I did most of my career, like working on this type of use cases and as a developer. So this is why like data scientists become more as a data engineer today. You're taking some sample code from GitHub and you embed it within your data. What's not different, like if you need to do it yourself, you always need to clean the data, do the feature extraction, create the data that will be ready for you to build that model. But if you are working for an organization or a company that you don't have that skill set in-house, this is new from actually Monday, Amazon Machine Learning Solution Lab. So we took our researchers and machine learning practitioners, and we offer customers to come and help you. And we can come on site, we can join to calls, but the idea is that we can brainstorm, because you always need to start with the use case. Yes, I have an idea. Can I use ML? Can I use AI to do that? But help you to build a custom modeling. If you have, for example, a specific use case that you cannot solve with APIs that exist today, you want to build something that is unique to your business, so we can help you to do that. We work with some companies that, like, for example, Johnson & Johnson or Toyota Research Group. We have several logos that already using this service, but also for training or just consult with us. So we have that feature. If you go to our website, there is a form you just need to fill. If you have an account manager, contact him and we can connect you with our groups that does it. So again, this is quite new. We also announced today our partnership for machine learning. So we have AWS partners for machine learning. So it's a competency. So if you are a startup that are doing something interesting with machine learning and you want to sell your model or your product within our Amazon Machine Learning Partnership Marketplace, so that's something that was announced today. and we're very excited about it. We have many partners that join to that ecosystem. So again, because it's an introduction level, and we really think we want to enable and empower you to use AI to build the software, let's run a demo. So I need you to take your mobile app, or just your mobile phone, and go to this website. So just use your phone. I'll take mine, so we'll do it together. Where is my phone? Ah, you have my phone. Yeah. Raise your hand when you're on this website. So what we're going to do, I'm going to ask you to take your selfie. We are not storing your picture, don't worry. They are not stored on S3 or anything. So take your selfie, and anyone already took a selfie and used photo? So you will see labels that come from, I'm doing it with you. Raise your hand if you already did it. Okay. Yeah, so let's do this. I like to do it like that. This half, take again a selfie and smile. This half, don't smile. Let's try it. So, and I'm going to switch to a different screen. Oh, Chris, I need your password. You cannot say that. So, again, the age range, I always get insulted because of that, but I don't know how it worked for you. But so this is you guys. So we have around 96 people. And this is live stream from your phone. So what we do here is basically, so the median age here is around 38. I see that we have half of the audience wearing glasses. Half of you smile, so actually it works, right? So yeah, the count is still growing, but and as you can see, you see live the graph. What we do, we also stream data from your phone, so I know which mobile app you came, and we have some interesting statistics. And so thank you for taking the selfie again. We don't store these pictures, but what I captured actually within this demo, I'll show you the architecture and how we build. So by the way, if you want to see the source code, just view the source of that link, and you can see the entire code. There are not many lines of code. And this is the architecture of building that type of demo. And then Chris will show you how they actually use it for real things. So, which is real. Like, I have customers that actually use that to build. We have questions in the end. So.
Right now, he thinks I have bird.
He thinks you have bird. Again, it's a model. It's a confidence level. So there is, when you look at the API of Rekognition, when you send an object, you get all the labels and a confidence level. Can have 70%, 80%. So I put a criteria like showing everything that is above 70%. I can change the if and say, like, show me only the ones that 90% and above. So, and again, getting a confidence level, it's based on models that we build. We need to retrain sometimes, etc. So, but let's focus on how we build it. So we use a service called Amazon Cognition. So Amazon Cognition it's an API that you can take from your mobile, for example, capturing which mobile phone you're using, if it's an iPhone, Android, Windows Phone, etc. And I'm using Amazon Rekognition here to send that picture and getting in back a JSON object with the labels and the data that we capture. Then we stream the data to Amazon Kinesis. In Amazon Kinesis, we are using the service called Kinesis Analytics that actually can build this group by and the aggregation. So I can show the statistics of how many people, what is the median age range, for example. I want to see the user count as a graph, like if you have more users, etc. So you can think about like IoT or devices or smart devices, but it can be anything. So we use Kinesis Analytics to build this aggregation. And eventually, we stream these results back, and this is how the query, like, it's built, for example. We stream the results back to another Kinesis stream. We use Lambda. Lambda is our serverless compute service. Store it in DynamoDB, and then I show you a live dashboard. And as you can see, it's a real-time, near real-time. Like, there is like 4 or 5 seconds delay between the time you took the picture. You will get the labels, and when I can display the dashboard What's interesting about this one, the cost to run this entire infrastructure for up to 1,000 users that take pictures in real time is less than $200, actually, in a month. That's the infrastructure. And you don't manage any EC2 instance. It's all serverless. So the entire code, we build it with Kinesis Analytics, streaming it through Lambda. It's all serverless, that you don't need to manage servers. And let's say that you have now millions of people that are taking pictures. So that will automatically scale. Of course, for Rekognition, you might need to fill a form because there is a soft limit that we put. We don't want you to pay too much for services, but you talk to us if you need, like, for example, millions of images to be scanned in every second, as well as Kinesis. Kinesis has soft limits, etc., and we're doing it just to protect you and the cost. But the idea is really to build and innovate your software using this type of services. So hopefully you enjoyed this demo. I just give you an idea of that. You don't need to be a data scientist to use AI to really innovate and improve your software. And if you think about every software vendor today is using machine learning within their own software. This year we announced Amazon Macy that actually can scan S3 and can tell you, hey, you have some PII information, and can identify some patterns with using machine learning, like social security and things of that nature. So we are also doing that as well to other services, and they're smarter. So with that, I welcome Chris Azima to talk about how they actually catch criminals. I told him I wanted to be a demo on myself, like, can you find me? Like, but then I said, no, you know what? Don't do that. But thank you, Chris. I'll be here. Yeah.
All right.
Yeah, I will be back.
So, as Roy said, my name is Chris Adzema. I am a senior information systems analyst for the Washington County Sheriff's Office in Oregon. And I wanted to share with you guys what I've been doing over the last year since Rekognition was announced at last year's reInvent. Around that time, we were coming up with the idea that we needed a quicker and a better way to identify unknown suspects. Previous to the solution that we implemented, we would have to send out emails that look very similar to this, where we would have the pictures and we would rely on law enforcement officers who possibly knew that person to reply back to that email. Problems come in where it takes too long to get a response. Maybe the people who knew that person have already moved on from the agency. Maybe that person doesn't work for 3 weeks. So we had a really long turnaround, and we were missing out on leads that we could possibly get. Now, what we decided is what if we could find a way to utilize machine learning to identify people? And so around that exact same time, Amazon announced Rekognition, and I decided to make a test of it. So I uploaded about 300,000 of our booking photos or mugshots into the S3 cloud and indexed them with Rekognition. And it allowed me to run the searching API and return results within seconds. Let me show you some code here just really quick, because I want to emphasize how easy this was for me to set up, not being a data scientist and not knowing anything about AWS prior to starting this. In 3 easy steps, I was able to create the collection of the 300,000 mugshots. You simply create a client. I'm using PHP here, but it's going to work the same in any of the SDKs you use. You list out all the objects that you put in S3. In my case, I uploaded S3 manually using the web form, but you could do it programmatically as well. And then for each thing you list out, you just run an index face on it. And now you have a complete index in Rekognition of all of the images you need. Then the next step, again, pretty simple. To search, you just have to have the file data, whether or not that's in the form of a post like I have here, or you can even upload it to S3 and have it pull from S3, and then do search faces by image, and it will return the results. really quick look at the architecture here, you can see that it's pretty simple. All I'm using is either the server to make the calls directly into Rekognition, or we have a mobile app that we use Cognito to interface with the same collection. I wanted to show you guys 3 real-world examples here. If you recognize, this was from the first email that I showed you guys. This gentleman walked into a big box department store, put a bunch of stuff into his cart, walked up to a self-checkout, proceeded to scan everything, but then put the stuff back into the cart and walked off and didn't pay. Luckily, there's a camera on each self-checkout kiosk, so I ran it through Rekognition, and I got 4 results. And I noticed that the one on the bottom left corner there looked very similar, so I pulled up his information, gave that name to the deputy in charge of the investigation. He quickly went to Facebook, looked at his public profile picture, and found this. So within minutes, we had an unknown suspect to a pretty good idea that this was our guy, simply because he doesn't know how to change his clothes when he's robbing a place. Needless to say, we were able to apprehend him and find the merchandise on him at the time because we were able to work so quickly. Another example is, well, I wasn't there, unfortunately, but I can tell you that typically people know that they're not surprised when they're caught, in most cases. This guy, we received a tip that somebody knew that somebody had a warrant out for his arrest, and that's all they told us is, I know this guy has a warrant out for his arrest, and he didn't know his name or anything. And the reporter took the picture of the person and then held it up to the deputy and said, it's this guy. Well, the deputy took a quick picture and was able to run it through Rekognition. Now, the reason why I wanted to show you this one is because there's so much glare and so much things. It's turned sideways. You can actually see half the deputy's face in the picture. But when we ran it through Rekognition, Rekognition was able to see past all of that and return us this result. And within seconds, showed it to the reporter, and the guy said, yeah, that's the guy. And he indeed did have a warrant out for his arrest, and we were able to apprehend him based on that information. And the final result, so the final example I wanted to show you guys was kind of exciting because it was something we didn't even think about when we first started this project, which was artist renditions. So you see this a lot where we don't have a picture, but an eyewitness comes in and gives us a sketch, and an artist will draw it up, and they'll show it to the eyewitness and say, is this the person? And they'll say, yes, it looks like that, or no, you need to tweak the eyebrows or whatnot. But I was able to run this through Rekognition and get an actual result, something that we could go and investigate further based solely on a artist's image, which is extremely powerful because we don't always have cameras, we don't always have video, but if we have an eyewitness, we could probably get an ID now. All right, so I wanted to show you guys a quick demo of both the web version and the mobile app. So first, forgive the UI. I'm a back-end developer. I don't do UI well. But so I want to show you how quickly this does this. I'm going to select an image here, and within a couple of seconds, I'm going to get the results back, and it's going to show me everything I need to know about this person. Now, in this case, this guy was being disruptive, and the deputy needed to get his information back really quickly. He was able to use the app, get this information, and know that he was a danger because we know of this person. But as you can see how quickly that worked, that was chewing through 300,000 different images, getting us the results both, which ones were good results and the information for that in that quick of a time. And we can scroll through and see the results, seeing some of them aren't real, but also here's another picture from a different booking from the same gentleman. And then I'm going to show you another quick one here that we just pulled off of Crime Stoppers today. And again, this one shows you that he cut his beard, but we were able to identify him very quickly, even with a different, that much facial hair difference. All right, now let me put on the mobile app just to show you, again, how easy it was to create. Excuse me here. All right, there we go. There we go. So I'm gonna take a picture here of this handsome guy and run it through. And this one's gonna take a little bit longer because it's actually authenticating through Cognito and doing a little bit more than the web version has to do. But you still get the results back quite quickly, and again, all that same information that you got on the web version. I've got this in the hands of deputies now. They can get this information in seconds as opposed to hours. So it's been a very helpful tool. One more thing about the mobile app I wanted to show was an idea that I didn't even think of, again, when I created the mobile app, which was sometimes a deputy has a person in front of them, and they know who they are because they have the driver's license. But what they don't know is, has that person been booked into jail before? Is this person a danger? Because some people who come through the jail and get released are still a danger to deputies for one reason or another. Well, they were easily able to take the picture from the driver's license, run it through Rekognition, and get a result back that said, yes, this person had been in the jail. In this case, she wasn't a threat, but they were able to have that information quite quickly. Now, the next big thing that's coming for us is we are going to start integrating with other agencies. Right now, the booking photos we have are only our own booking photos. But we want to be able to reach out to neighboring agencies because criminals don't abide by county lines, and we need to be able to know who's been booked into a neighboring county jail. This is done very quickly and easily, again, by having them set up the same thing that I set up, which I was able to do it in a couple of days. And we utilize the IAM STS to actually just inherit their permissions and run searches off of their results. It's rather simple. It's done the same way. Once you inherit the results, you just do the search as if you were them. And the thing that I'm going to be working on next to utilize is this system that we call Help Me Home. Now let me give you a little bit of background about Help Me Home. This is not for criminals. This is not for catching people. This is a system that we utilize for endangered elders and endangered kids, elders with dementia, children with autism spectrum, who have the propensity to walk away from home and not know where they are and not know how to get home. This database we currently have utilizes age, height, weight, things like that, so that we can search for these people so that if we come across somebody who could be in that endangered population, we can know how to deal with them. In this case, this young kid, he's on the autism spectrum, and if you read here, it says that you need to be able to call out his name, make eye contact, wave hi, or he could end up becoming physical, biting and hitting. Well, without the information as to how to approach the person, the deputy's in danger and the child is in danger because he's obviously not going to be treated well if he's sitting there biting a deputy, simply because we have to keep everybody safe in this situation. But the problem is that the deputy's not going to have enough time to pull out his computer, go to a website, fill out this form over here, and search based on what age he thinks the kid is, how tall he thinks he is, stuff like that. If he can pull out his cell phone, take a quick picture, then return the results, he'll be able to have that information much quicker and be able to action it and know how to approach that person. So that is the next thing I want to do to kind of help keep our community safe and help more people, because while identifying criminals is fun and all, this is the stuff that really helps people and really makes sure that we're all safe. So kind of already touched on all these things that have been great. We've been able to go in the past year, gone from taking minutes and hours, sometimes days to seconds to identify these individuals. We've also been able to learn everything we know currently about AWS with very little instruction, very little help, because they've made it so easy for us, and it's allowed us to open up to other products that AWS has that we weren't using before. And then we've assisted in identifying many cases. Some of these have already gone through court, some of these have already had convictions, and we've been able to utilize this where we weren't going to be able to identify them previously. That's it for me. I think that, as you can see, it was really easy for somebody who's not a data scientist to utilize artificial intelligence to help something out very nicely. And I'll give it back to Roy.
Yeah, just final act. Thank you very much, Chris. It's great use case. You know, it's 200 session, but I always like to finish with some call to action, and that's to you. First, thank you for coming here and attending this session. Leverage Amazon AI when you build software. Start with the top stack, right? You try, because there are some problems that are very simple that you can just utilize this type of APIs. Another rule of thumb, try to go serverless first. In my opinion, if you can build something that scales. Data has gravity. If you need to do it yourself, make sure that you have the data sets that can help you to train and build the model. And if you really need help, check our Amazon and Machine Learning Solution Labs. We are really excited about this opportunity to help you, your organization. If you have a startup idea, there is no field that we don't see AI, machine learning is not applicable to. This is why it's very popular. Go to hear more sessions. If you want to build a smart bot, go to Amazon Lex session. Again, we wanted to give you just an intro, sneak peek. We picked this use case because, you know, Chris and I, we talked, and are you a data scientist or deal with that in the past? No.
No.
And really, it's amazing, how you build software. So, again, this is some of the call to action. We'll be here for Q&A if you want to come over. And thank you very much for coming here, and enjoy the rest of your event. Thank you.